You ever wonder what's really happening inside your phone or your laptop when you tap on an app? I mean, it feels like magic, right? But it's actually this incredible stack of technology with layer upon layer of absolute genius. So today, we're going to go on a little journey. We're going to peel back those layers to see the hidden world inside our devices. Our descent begins now. We all live right up here, at the top. Level 6, the user level. This is the world of executable programs, or, we just call apps. It's the friendly, familiar face of all our technology. But the big question for our journey today is, what's going on underneath all this? What actually has to happen for your favorite app to even work? So, let's start our journey at the top, on familiar ground. This is the layer we deal with every single day. The application layer. You can think of it as our home base, right? It's the world of software that's been designed specifically for us, the people actually using the computer. At its core, application software is pretty simple. It's any program built to do a specific job for you. When you're editing a photo in Photoshop or you're writing up a document in Word, those are perfect examples of tools that exist on this very top layer.
And in today's world, we usually get these applications through something called software as a service, or SaaS for short. So instead of buying a CD in a box, you're basically subscribing to a service. And you use these all the time, probably without even thinking about it. Gmail, Netflix, Dropbox, they are all classic Level 6 applications delivered to you right over the internet.
Okay, so you click play on Netflix. How does that one simple human command actually turn into a movie playing on your screen? Well, that command, it has to be translated. It gets passed down through all these different layers until it becomes a language the machine can physically understand. It's a whole chain of command. And this is basically the ladder it has to climb down. We start up at level 5 with high-level languages like C++ or Java. This is what developers actually write the software in. It's kind of readable to us humans. But then that gets translated down to level 4, assembly language, which is way more cryptic and a lot closer to the hardware. From there, it passes through level 3, the operating system, which gets it ready for the final step, turning it into level 2, machine language. We're talking raw ones and zeros, the only language the computer hardware actually speaks. And right in the middle of this whole process, acting as the master coordinator, is the operating system, or the OS. Think of it like the traffic cop for the entire system. It's that essential software, your Windows, your Mac OS, your Android, your iOS, that manages, well, everything. It's what allows an app like Netflix to actually talk to the physical hardware, like your screen and your speakers. I mean, without the OS, it would just be total chaos. All right, so we've followed a command from our fingertips all the way down to the machine's native language. We have officially crossed the boundary from the world of software into the physical world of hardware. We're talking about the machine itself. And you know what? The blueprint for pretty much every computer you've ever used is this thing, the von Neumann model. It's actually a beautifully simple design. You've got your input devices, keyboard, mouse. You've got output devices, like your screen. You've got memory for storage, and then connecting and controlling the whole shebang right in the center is the CPU. This is the fundamental layout.
Now, the absolute heart of this whole thing is the central processing unit, the CPU. It really truly is the brain of the entire operation. All those instructions we translated down, they finally get executed right here. This is where the thinking actually happens. And this brain has a couple of very important parts.
So inside this brain, first up is the control unit, or CU. If the CPU is the brain, you can think of the CU as its director. It takes those ones and zeros, it figures out what they mean as instructions, and then it tells all the other parts of the computer what to do next. It's the conductor of the entire orchestra.
The other half of the brain is the arithmetic logic unit, or the ALU. This is the calculator. The control unit gives the orders, and the ALU does the math. It handles all the addition, subtraction, and all the logical comparisons. Every single complex calculation you can possibly imagine boils down to the super simple operations happening right here in the ALU.
So where does the ALU do its work? It uses these things called registers. Now these are tiny, incredibly fast storage spots located right on the CPU chip itself. The best way to think of it is as the CPU's personal little scratch pad, where it holds the numbers it's working with right this second. Now, beyond that tiny little scratch pad, there are two other really important kinds of temporary memory: cache and RAM. Here's a great way to think about them. Cache is like your workbench. It's small, but it's right there, holding the tools you need right now,
and it is incredibly fast. RAM? RAM is like the giant warehouse out back. It holds everything you could possibly need for the whole project, but it takes a little longer to walk over and grab something. The computer is constantly shuffling data between these two to keep that CPU fed and working at top speed.
Okay, so we've looked at the computer's brain and its memory. But believe it or not, we can go even deeper. We are about to hit the absolute bottom of this entire hierarchy, the physical foundation that everything else is built on.
And here we are. Level 0. Digital logic. This is it. This is the bedrock, the absolute ground floor of computing. You literally cannot get any more fundamental than this.
Down here, forget about code. Forget about programs. We're talking about physical circuits, and these tiny little switches called gates. And these gates can only be in one of two states, on or off, a 1 or a 0. This is the exact moment that machine language stops being some abstract idea and becomes a physical reality, an actual electrical pulse flowing through a wire. This is where code becomes action.
So, wow, we've taken a journey from a simple Netflix icon all the way down to a single electrical switch. It's just an incredible stack of abstractions. So now, let's pull the camera all the way back out and see how this entire stack is packaged up and delivered to us in the modern world.
And this brings us full circle right back to the cloud. We started with software as a service, SaaS. That's where you're just using the final application, like Netflix. But cloud computing lets you buy access to the deeper layers. So you can move down to platform as a service, or PaaS. Here you get the hardware and the operating system, and you build your own apps on top. Or go even deeper to infrastructure as a service, IaaS, where you're basically just renting the raw hardware, the servers, the CPUs, the memory. You rent the foundation and you build everything else yourself. It's all just different ways of slicing up that same hierarchy we just explored.
So after this incredible journey, from the app you can touch on your screen all the way down to the electrical switches firing inside, which layer do you think is the most important? The application, the operating system, the CPU that does the thinking, or those simple little on-off switches at the very bottom? The reality is, they're all absolutely critical. You take just one of them away and the entire magnificent structure just comes tumbling down.